Welcome to Carbohydrates Everywhere, but how much do we need? Before watching this, make sure you've watched the introduction to carbohydrates to get the context that you'll need to understand this particular module. The amount of carbohydrate, particularly sugar, in many foods and drinks will probably surprise you. Hopefully this will encourage you to read labels. No dietary approach is going to work if what you, your clients, or your audience think they're eating is inconsistent with what they actually are eating. So, how much carbohydrate, especially sugars, are in common foods? Here are some nice visuals from the folks at sugarstacks.com. Okay, so this may not come as too much of a surprise. You expect soft drinks to contain a lot of sugar. But did you know that fruit juices can contain just as much? What about fruit? It is sweet, so it should come as no big surprise that it also contains sugar. And by drying fruit, the vitamin content is reduced, and much of the water, of course, is removed, but all the sugar remains. Because of the missing water, which normally would provide a lot of bulk, it's actually much easier to overconsume dried fruit than whole or undried fruit. I'm always perplexed at supposedly low sugar recipes that are loaded with dried fruit. After watching the carbohydrate introductory module, it should be clear that this is at best marginally better than just adding table sugar. And it's actually worse for your teeth as the dried fruit really sticks. Also, watch out for low-fat yogurt, low-fat anything actually, as extra sugar is often added to make up for the taste and texture that would otherwise be provided by fat, like in this example. Much as drying fruit concentrates more sugar in a smaller bite, juicing fruit also makes it easy to overconsume, as the fiber and therefore the sense of bulk is removed, but almost all the sugar remains. Make your own juice and see how many oranges you have to squeeze to fill a large glass. Now think about it. Would you eat that many oranges in one go? Now you may have slightly different sweets and snacks where you live, or have different preferences, but chances are they're just as high in sugar as these examples here. And manufacturers will often emphasize certain ingredients deemed healthy by highlighting them or hinting at them on the packaging, a tactic that creates what psychologists call a health halo. And we'll look at this some more when we talk about labeling, etc. As you can see though, just because something has a few ingredients that are touted as healthy doesn't mean there isn't plenty of sugar tucked away as well. Condiments also often hide a surprisingly large amount of sugar. And not knowing this can really get in the way of, say, very low carbohydrate diets, where people add condiments and they don't actually realize that they're adding a teaspoon or more of sugar each time they have a little bit of sauce. Now, every so often, the fact that sugar in carrots is rapidly absorbed by the body makes the rounds. We'll get back to this. Now, although it's true, it's irrelevant. Look at how many carrots you would need to eat to get the same amount of sugar as one typical chocolate bar. There's just no competition. Enough of the nice pictures and sugar cubes. Hopefully it was sobering. And it's even more sobering when you realize that a healthy blood glucose concentration is roughly consistent with having just 1 teaspoon or cube of glucose in your entire bloodstream. Now, of course, you probably have questions like how much carbohydrate, what carbohydrates, when, and, well, what are good sources of carbohydrates? It's a lot like asking what carbohydrates. Here it's going to get a little more involved, as we'll touch on type 2 diabetes and some related conditions such as metabolic syndrome and fatty liver, just because those are fundamentally linked to diet and especially carbohydrates. So how much carbohydrate? Once again, it's one of those how long is a piece of string questions. How much carbohydrate would be most beneficial for a person depends on the type of diet they follow, the types and amounts of exercise they do, their total energy needs, the health of their metabolism, and also their personal health, performance, or even weight or body fat related goals. A question like this is only easy to answer for those with a one-size-fits-all solution, which is really no solution at all because we are all different. Having said that, most people are going to do well by reducing either the amount of carbohydrate in their diet or reducing the amount of fat in their diet. Which option is likely to work best is going to depend on how well their body copes with glucose and therefore carbohydrates in general. If someone is trying to get leaner and has glucose intolerance, meaning they have an insulin resistance. So resistance to the hormone insulin, which is basically in charge for much of the regulation of carbohydrates, how they get used, where they go, whether they're stored as glycogen or stored as fat, or they have metabolic syndrome or impaired glucose tolerance or impaired fasting glucose, all diagnosable conditions, or for that matter, type 2 diabetes. In any of these situations, carbohydrate reduction makes the most sense. It's not the only option, but it certainly makes the most sense, and we'll look at this a little bit more. And then this may, well in fact it does run counter to common advice, but it makes an awful lot of sense when you think about it. It's fairly intuitive and sensible to avoid things we tolerate poorly, at least in food terms. So if you have a diagnosis of impaired glucose tolerance, it would make sense to reduce glucose intake. The bonus question is, what do we need carbohydrates for? We do need glucose because some of our cells cannot use any other fuel source, or at least are partially dependent on glucose. But as I mentioned earlier, our bodies can make glucose from other nutrients. So dietary carbohydrates are not strictly speaking essential to life. We can generate them through the process mentioned in an earlier module called gluconeogenesis, the making of new glucose from some amino acids and from glycerol that we get from fats. Realistically though, it's almost impossible not to consume some carbohydrate when eating a diet of whole foods. And it takes a period of a few weeks to more or less fully adapt to cope well on very low carbohydrate ketogenic diets. As well as certain cells needing glucose, certain activities are also very dependent on glucose. Any high intensity physical activity, for example sprinting at maximum speed or lifting heavy objects, is going to tap heavily into our stored glucose. That's just how our bodies work. Many of us these days have actually become what's been termed metabolically inflexible. This is a fancy way of saying that our bodies are bad at switching between using carbohydrates as fuel to using fat as fuel. I've seen this personally time and time again in the lab with people basically trapped in carbohydrate burning mode all the time, even when they should have been burning their stored fat, such as when they're resting quietly. A person with good metabolic flexibility will be able to fuel most of their activity with fat, but even they will rely on glucose for high intensity activities. Low intensity activities such as long walks or long, slower runs, swims or bike rides can be fueled more heavily by fat when metabolic flexibility is good. In people who have lost their metabolic flexibility, it will take days to weeks of appropriate exercise and nutrition to regain it. It's well worth it though, as restoring metabolic flexibility is essentially a part of restoring good health. Let's explore this concept a little further with a graphic. First, a few terms. Respiratory quotient, or RQ, is based on how much carbon dioxide you breathe out and how much oxygen you breathe in and actually retain and use. As we'll see in a later module, oxygen is what is used up when our bodies convert food into energy, and CO2 is what is produced. Now, respiratory quotient is shown on the bottom of this graph and ranges from 0.7 to 1.0. The other axis shows how much a person is relying on carbohydrates and how much they're relying on fat at any given respiratory quotient. The higher the respiratory quotient, the greater the proportion of energy coming from glucose, carbohydrates. And the lower the respiratory quotient, the greater the proportion of energy coming from fat. Now that is somewhere we want to be if we're trying to get leaner, right? We're trying to use up our fat stores. Now the harder someone works physically, the higher the RQ goes, or the respiratory quotient goes, up to 1.0 in this example. Okay, we'll ignore the fact that temporarily we can go above this. It's more of a measurement error thing. And the closer to complete rest someone is, the lower their RQ will be, or their respiratory quotient will be. Theoretically, if you're at complete rest, your respiratory quotient should be low, somewhere sub 0.8, which would mean that you are mostly using fat as fuel, about 77% fat if you're at 0.8. And over 85% if your respiratory quotient was around 0.75. Unfortunately, a lot of people these days have a high respiratory quotient, even at rest. The average for my fatty liver patients was 0.89. So even at complete rest, after a minimum 10-hour fast, so also fasted, not just resting, and lying down in a quiet, cool lab, not much stimulation, and after about 10 to 15 minutes to relax, before we measured, close to 2/3 of energy was still coming from carbohydrates. And this was not unique in our research. This is common in today's society. Why is that important? Basically, because if someone's body is bad at using fat as fuel, how easy do you think it will be to use up excessive fat stores? Restoring metabolic flexibility and therefore the ability to rely heavily on fat as fuel should be a goal for anyone who wants long-term health. So how do we do that? We'll keep returning to that question as it relates to both nutrition and physical activity, as well as other lifestyle factors. The next question is, what carbohydrates? The concept of complex and simple carbohydrates is outdated. The assumption that so-called complex carbohydrates have a less dramatic effect on the body than simple sugars doesn't always hold true. As you learned in an earlier module, digestion is exquisitely developed to break down starches into glucose, and the liver is well suited to converting fructose and galactose into glucose also, at least if they're eaten in modest quantities. The idea that has in many ways replaced complex and simple carbohydrates is something called the glycemic index, usually abbreviated to GI. The GI, or glycemic index, is a reflection of how quickly blood glucose rises in response to a carbohydrate-containing food or meal. All else being equal, a high glycemic index food will result in a faster and greater rise in blood glucose than a moderate or low GI food. So high, earlier, bigger spike in red, low, nowhere near the spike, and it comes a little bit later. So lower GI foods are therefore theoretically preferable under most circumstances, as they provide our bodies with more time to keep blood glucose in check and within healthy ranges. Unfortunately, the glycemic index is not without its problems. Far from it. Studies done to test the glycemic index of various foods and meals are often done in small numbers of people. There is variation from person to person and from day to day in the same person. So the food is not going to affect everyone to the same degree, the same way, and even the same person, maybe based on what they last ate, how well they slept, and so on, and what effects that's had on their metabolism, will not react the same way to the same food each time. Also, factors such as food preparation make a difference. For example, bread that was previously frozen gives a different response than bread that wasn't, and bread that's toasted gives a different response to untoasted, etc. Despite this, the broad classifications like low, moderate, and high are reasonable and potentially even somewhat useful. A more serious issue is that glycemic index tests require a standard amount of carbohydrate to be eaten, usually 50 grams or sometimes 100 grams. And this doesn't always reflect how we consume food in real life. For example, carrots have a high GI. But to do a classic GI test, and I have to assume they didn't do a classic test for carrots, you'd be required to eat over 700 grams to get the 50 grams of carbohydrate. And that's also somewhat true for blueberries. In contrast, you'd get 50 grams of carbohydrates from about 1¼ cups of cooked long grain rice or a cup of raw oats. Another big effect is what else you eat with your meal. We usually don't just have carrots or just have blueberries or just have rice or just have oats. Maybe oats as porridge, we mostly have just oats. But everything else we're likely to have as part of something as a total meal. So we have these things in combination with other foods to make a meal or a snack. And the meal will be more than the sum of its parts. So the fat content and the protein content are going to make a difference to the glycemic response. Finally, although glycemic index is often considered particularly relevant to people with diabetes, actual tests in people with diabetes, either type 1 or type 2, have seldom been done. Only self-experimentation with a glucose meter or continuous glucose monitoring device can really show how an individual responds to a given food. And even in the same person, as noted earlier, there's going to be day-to-day variation. Factors that affect GI include things like the extent of chewing, the fat and protein in the food or meal, the specific type of protein, any processing, freezing, toasting, and so on were mentioned, the cooking method, and the state the person is in. Is it postprandial? Is it post-absorptive? Is it fasting? What was their previous meal? And what was their recent physical activity? Okay, so let's break down some of that jargon on that last slide. Remember these. Postprandial, that's the period immediately after eating. Basically, the food is still all in the stomach. Post-absorptive, that's the period after nutrient absorption has occurred, and that can be several hours after eating. And fasted, that's the period 8 to 12 hours after the last food. So we often talk about an overnight fast, but if you eat just before bed, sleep 7 or 8 hours, and then immediately have breakfast, you basically have not been in a fasted state. And we'll talk about the concept of time-restricted feeding and intermittent fasting when we talk about different dietary approaches. So the key message here is how we respond to the carbohydrates in a meal depends on many factors. What I've just covered is not news to experienced nutrition researchers or even avid self-experimenters. So attempts have been made to improve on the glycemic index idea, to take into account the amount of carbohydrate consumed. And that gives us the glycemic load. Of course, this only addressed the problem of quantity, not the other limitations of glycemic index already mentioned. Earlier I said that despite sometimes being marketed as an important tool for people with type 2 diabetes, glycemic index was seldom tested in this group, but it has been in relation to legumes, and here are some of the results. Have a look at these graphs of glucose response, so changes in blood glucose concentration, to some meals containing rice and chutney as the base, and then changing the type of bean or lentil used to complete the dish. All the meals are also compared to a standard glucose test, which simply involves drinking a glucose drink, usually either 75 grams worth or 100 grams worth. Now on the left is the blood glucose response in people with normal glucose tolerance. You can see a glucose drink still makes the blood glucose shoot up a little, but all the meals, whether they included chickpeas, green, black, or red gram, or lentils, had a fairly modest effect. And that's consistent with the relatively low glycemic index of these foods. In contrast, in people with type 2 diabetes, all the meals cause blood glucose to rise substantially and stay up for a long time. Prolonged high blood glucose is detrimental to blood vessels and nerves as well as other tissues. That and chronically high insulin are what basically causes the problems we associate with type 2 diabetes. The difference in the effect of these meals between those with normal glucose tolerance and the glucose intolerance of type 2 diabetes is even more obvious when we look at the blood insulin response. Now, as already mentioned previously in other modules, insulin is a hormone produced in response to increasing blood glucose. It acts like a traffic controller for glucose and less directly for fat and amino acids. It helps to determine where in our bodies glucose goes and what happens to it once it gets there. On the left, in people with normal glucose tolerance, we see a modest rise in insulin in response to these foods, and a substantial rise to just the pure glucose. This makes sense as insulin is responsible for directing the glucose from the meal around the body. We'd expect a response. On the right, we see a much greater rise in insulin, and this is consistent with type 2 diabetes, at least in the early years, in which people's bodies are resistant, or if you prefer, somewhat deaf to insulin. More insulin, much more insulin is needed to do the job. It's often assumed that lower glycemic index foods like beans and lentils require less insulin to be properly processed by our bodies. But we can see here this isn't as clear cut in people with type 2 diabetes. For example, the blood insulin response to red gram and black gram is still going up after 2 hours. So even with these lower GI foods, the body of someone with type 2 diabetes has to work hard to process the carbohydrates contained. And again, this highlights another limitation of the whole glycemic index concept. One key message here is that glycemic index is at best a way of comparing foods, not a way of predicting specific individual responses to carbohydrates. Likewise, glycemic load is at best a way of categorizing diets. A high carbohydrate diet with a low glycemic load may still be problematic for people with impaired glucose metabolism, for example, type 2 diabetes. The next question is when? Our bodies cope best with carbohydrates after physical activity. They actually cope best with fat and protein after physical activity as well. Why? Because muscle contraction takes energy, and that energy comes from the breakdown of stored glycogen and stored fat. After physical activity, especially prolonged and or strenuous physical activity, more of the nutrients we eat are shuttled into our muscles. The effects are increased insulin-independent glucose uptake. That means the muscles will take up glucose from the blood even when the hormone insulin is not elevated in the blood, or when there's a degree of resistance to it. Insulin does help muscles to absorb glucose, but contrary to a myth that's still found in many textbooks, it is not the only thing that does. Forceful muscle contractions have an effect similar to insulin on skeletal muscle. There is also an increase in sensitivity to insulin when it does go up. So increased insulin-dependent glucose uptake. And that same increased sensitivity to insulin increases amino acid uptake and also increases uptake of lipids or fats into the muscle. The key thing is that these are only true for the muscles involved in the activity, that is, the ones that contracted forcefully. And this is why it's preferable to involve as much muscle mass as possible to promote health, and emphasize the use of large muscle groups such as those of the legs and the back. On the other hand, poor sleep quality and or quantity make us less responsive to insulin and therefore less able to healthfully metabolize carbohydrates. So, whether your overall diet is high or low in carbohydrates, have your highest carbohydrate meal after being most physically active, especially on days following poor sleep. So with all that said, what are some good sources of carbohydrates? On a reduced carbohydrate diet, good sources would be things like berries, yams, pumpkins, squashes, beans, and lentils, depending on your tolerance of those things, of course, as well as what you might know as kumara or sweet potato, depending on where you're from, although that's probably to a lesser degree. These are all also fine on a high carbohydrate diet, and in addition, you could also include things like potatoes, rice, and various other grains and grain products, again, depending on your tolerance. As with previous recommendations, go for minimally refined foods, although probably for rice, it is better to go with white rice because of some of the contents of the brown rice.